DJ Shy. Can you hear me through the Teams?
Yeah. Yes, I
Perfect.
can.
And we can hear you very well. Excellent.
That can, for my presentation, could you not to record?
Could you repeat that again?
Can you stop the recording for my presentation?
Okay, recording has been stopped on your presentation.
I'm sorry.
Did you say stop the recordings?
Yeah, for my presentation, is that possible?
Yes, the recordings have been stopped for your presentation.
Okay, got it. Thank you.
So when you're ready to go.
All right, good afternoon, everyone. We're going to get started for our afternoon session, emerging technology, focusing on 5G this afternoon. I have the pleasure to introduce Dr. DJ Shai. He's with MITRE. If you go to these sorts of events, you've very likely seen him speak before. He's well known at events like this, as well as IEEE, Milcom events, and things like that. He is well known for his work in dynamic spectrum sharing, and analyzing the interference issues that come along with that, as well as a transect. So we're happy to have DJ briefing us today. And DJ, just a reminder that this is considered an open forum, so no COI, all unclass information that we'll be discussing in the room here today. So DJ, over to you.
Got it. Thank you, Andy. Can you hear me?
Yes, we hear you. Okay, please go ahead.
Yeah, thank you. Hi, Dad. So first, I'd like to thank Brian for accommodating my presentation. Also, I can thank Andy for the introduction. So let's get started. The title for today's presentation is 5G coexistence techniques in Orange. So let's take a look. Next slide. So in terms outline for today's presentation is that I can provide an overview of 3GPP interference
DJ,
management. I'm sorry.
could you go back a slide so just so we can get a picture of your slide deck before you go on?
Sure, no problem. No, okay,
Just a
got
photograph
it.
of your opening slide. Thank you. All right, you can press on.
Okay, okay, sure, no problem. Just stop. Please interrupt me anytime. And, so first, I'm going to provide an overview of 3GPP interference management techniques as a foundation when we discuss 5G transect as well as DSS, dynamic spectrum sharing. Then we're going to provide definitions for transect and DSS. So we could be on the same page. As you can sense that for transect, the definition is concrete, but the definition for spectrum sharing that is not unified. So we can discuss that a little bit more later. Then after that, we're going to explain how Orange changes the paradigm of conducting dynamic spectrum sharing and why that is the case, as well as major effort of engaging Orange Alliance standards to add 3GPP interference management techniques and what is the impact. Then we'll provide summary and conclusion at the end. So I already explained this slide already, but one thing I want to note is that the 3GPP interference management techniques that actually apply to both Transect and DSS, as well as energy saving, believe it or not, because all the use cases fall under spectrum agility that discipline. So basically so it has many applications. I want to make that point. And I'd like to spend a few minutes on this slide. The reason is, as I mentioned, this established foundation for interference management in a 5G network. I think probably put in context is easier for you to understand that I'm pretty sure everybody has a cell phone in the room that could be from Verizon, could be from AT&T, could be from T-Mobile. And the design principle of any 4G or 5G network is that every cell, every base station or any base station in the network, they all use the same frequency at the same time. So this is different from the traditional cellular, where the frequencies are divided into and allocated to different cells. So you're going to ask that if all cells, all base stations are using the same frequency at the same time, when they create interference between cells? Yes, it does. That's the reason 3GPP spend time and the standardized multiple categories of interference management techniques. So we're going to address one category at a time. The first category is based upon the principle called intercell interference coordinations. From the name of the technique, you can see that basically that if the RF the spectrum, the RF resources that can be among multiple cells or neighbor cells can be scheduled in a coordinated way, then it's possible that interference of the users, especially near the cell boundary or cell edge, can be mitigated such that the quality services can be improved. So I think it's easier for you to provide like a picture for you to understand the rationale. So I will jump over to slide 31. So I can see that on the right hand side, there's a depiction of a resource block that used by 4G or 5G base station to allocate resources to different users. So that's called RB in both frequency and time domains. And in order to support ICIC is that the two-dimensional resources, actually RBs, used by a group of users in one area for a cell is not scheduled by other cells in that area. So basically, RBs in other cells are blanked. It's called PRB blanking. I'm not certain you heard that term or not, but PRB blanking has been used extensively in the spatial sharing community. So this is where it comes from. I just want to let you know the origin of PRB blanking. It comes from 3GPP. So let's go back. And so that's the first principle. ICIC works on frequency domain. The second one is to create the almost blank subframe on the time domain to mitigate interference. And the third one called FEICIC to implement interference cancellation on your mobile phones to further cancel interference. The next category is called the coordinated multi-point COMP. We're gonna skip that because I'm not certain any providers actually implements these features. But the next one is called carrier aggregations that has been implemented as well deployed by all 5G service providers in the United States. So how does it work? Basically, what it really means is that when your cell phone communicates with the base station, you are able to utilize multiple frequency carriers at a time. So typically, you only need one frequency carrier, right, to provide communications. But by definition of carrier aggregation, you can aggregate multiple carriers to improve your throughput, or data rate on your phone. And so that's really the primary reason to have a carrier aggregation. Then in this case, why carrier aggregations can be used to do interference mitigations? Think about that. Assuming your cell phone, is able to communicate with a base station using 3 different frequency carriers. There may be a different spectrum bands. Maybe one is 700 megahertz, the other one 2 gigahertz. In this case, that the base station always can choose a frequency carriers that do not interfere with, for example, a government communication systems to achieve the spectrum sharing objective. So Transact defined as measures applied to transmission in order to prevent interception or disruption of reception, and this kind of and other things. So this kind of concrete in terms of definition, Transact, it comes from the DoD document. But in terms of spectrum sharing, right, it actually is not unified. So let's go over the definition I surveyed that's one at a time. The first one comes from 3GPP. So very importantly, when you mention dynamic spectrum sharing in the 3GPP community, that they will consider spectrum sharing is between 4G and 5G. So that will cause confusion, right? For example, in military space, dynamic spectrum sharing is always referred to the coexistence between commercial 4G and 5G and a government communication asset, right? Whatever the asset is. But in 3GPP, they don't think that way. So we had to be very cautious in terms of when we say dynamic spectrum sharing to 3GPP, we cannot use the term anymore. So people create a new term now for dynamic spectrum sharing. They call managed spectrum sharing to describe the same use case. And the 5G Americas use dynamic dynamic spectrum sharing as an approach to adjust their respective operation to achieve efficient utilization of the same frequency range in time or space. And NTIA has similar definitions, but I want to go over DoD definitions. DoD definition really is that the most important criterion for spectrum sharing really is that you cannot degrade DoD missions. Really, that is the most important criterion for spectrum sharing to achieve when discussing spectrum sharing to in the DoD languages. The next one is highlighted in the White House National Spectrum Strategy. And there are two concepts in the National Spectrum Strategy. The first one is that they call dynamic spectrum sharing as well as secure spectrum sharing. They add a term called secure spectrum sharing that to improve coexistence. So basically that the spectrum sharing really, you cannot disclose identity of who you are sharing with. So this is also important to consider that in terms of the DoD spectrum sharing, that use case. Also, they also mentioned the concept of dynamic spectrum management system, which is similar to CBRS, if you are familiar with CBRS. And the last one is from National Spectrum Research and Development Plan, and they have a very precise definition DSS. I don't want to repeat that here because you can read that on the on screen. But I do mention that can in the end they can mention that can adjust and optimize spectrum usage in real time or near real time. I want to emphasize these two terminology: real time or near real time. This cannot be done in the traditional base stations like the one we have today in the field, deployed by the 5G providers. That why they mention that they use ORAN, Open RAN. And that's the reason I want to emphasize that by mentioning in real time or near real time, they sort of implying that we had to use ORAN to do DSS. And so exactly what is the 5G coexistence techniques? Really is a 3GPP layer 1 and layer 2 mechanisms to support the objectives of DSS and other use cases in spectrum agility. Okay, any questions so far from the room?
We don't see any so far, DJ, so please go ahead.
Okay, thank you. Okay, the next one, I'm going to go over this very quickly in terms of the 5G Transit Framework Initiative from the ODCL. By the way, this is from the sim.gov, so everything's in open space. And so basically, 2023, the ODCL had an initiative of developing a 5G transit framework, leveraging 3GPP 5G interference mitigation techniques, as we described previously. That's the reason I mentioned those categories of 3GPP interference management techniques to set the foundations. And so DODCIO hosted the 5G Transit Industry Day and Monitor back in March 2023. There were a lot of people and vendors joined that industry day. I would say many, more than 30, more than 20 vendors. And the scope of 5G transit include anti-jamming, LPI, LPD, LPG, which I think you're familiar with that if you're in the transit space. And also they want to leverage both 3GPP compliance, which are standardized by 3GPP community, those techniques we mentioned, as well as non-3GPP compliant, which we are modifying the 3GPP techniques. The problem with non-3GPP compliant technique is that now you cannot utilize the commercial off-the-shelf mobile phones anymore. The handsets like iPhone or Android phones, that is one concern in terms of using non-3GPP compliant techniques. So basically, most effort that for the 5G transit framework, we focus on 3GPP compliant techniques. I can imagine what the reasons are. And these are samples of 3GPP transit techniques we discussed at the interstate. From a glimpse of this list, I pretty much covered them, most of them already in my previous session in terms of presentation, in terms of enterprise management techniques. For example, carrier aggregation, PRP blanking, and others. So we don't have to repeat those here. But once again, on the right side, that we did mention that why we think that 3GPP interface management techniques can be a candidate to implement 5G transit because of Orange. And we're going to discuss that next in terms of why Orange changed the paradigm of doing either 5G transit or that dynamic spatial sharing. So I'd like to spend a few minutes on Orange. You probably hear a lot of hype and capabilities as well, maybe commercial, about how great Orange is and how much Orange can do, how much Orange can solve the problem for the current traditional RAN that it cannot achieve. That I would suggest that you take those, I would say, commercials with a grain of salt. That okay, let's look at what Orange can do from the specification viewpoint. Orange also, by the way, there's also Orange Alliance, similar to 3GPP standards committee. They also standardize specifications for different interfaces. As you can see on the right-hand side, that's Orange architectures. For example, you have E2 interface, A1 interface, or O1 interfaces. So they standardize that specification for different interfaces. On the right-hand side, you also can see that there's a CU, centralized unit, right in the middle. Also, there's a DU, that's a distributed unit. And a base station, a 5G base station, can be decomposed into CU and DU. And there's RU, basically that's remote radio head that you see on the cell tower. That's called RU. So, and there are different interfaces connect. The top is management framework, as well as in the middle, the near real-time rec and other components of the base station with the different interfaces. So now you sort of give it a quick overview what Orange is about. Orange really is right to make those interfaces open. In the past, for example, currently, if you look at base station, doesn't matter if they are from Ericsson, they are from Nokia, or from Samsung, or from Huawei, right? The one that is banned by US. All the interfaces I show on the right-hand side are all hidden. They're all proprietary. Nobody knows how they are implemented. So basically that the base station vendor are able to provide the whole base station by themselves without the help of any third-party vendors. So basically it sort of dominate the base station markets. And the Orange, the the vision of ORAN really try to open up those interfaces such that other smaller third-party vendors also has a stake that has a market share in terms of the 5G base station space. So now you know the reason to have ORAN specification, right? Is really to open up all the interfaces, right? And that's one main reason. The other reason is that once you open up the interfaces, you also can create intelligence to control and optimize the behaviors of base stations or functionalities. They call apps. App, as I shown on the right-hand side, that really is a software that can be hosted on the top, the management framework, they call non-real-time rec, or they can host it in the middle, in the near real-time rec called X apps. So you say, what's the differences between R apps or X apps? The R apps, the time scale is much longer, maybe in minutes. So basically, you don't have to change the behavior base station continuously very quickly. So like a policy-driven type of changing of the base station functionality. So that's called R apps. How about what happens we want to change the base station functionality very quickly? For example, to support spectrum sharing. In that case, you need the X apps. And X app can work in a time scale of tens or micros, 100, tens or hundreds of milliseconds. And also that third category called D apps, which it can work in real time in less than 10 milliseconds. But D apps still a research stage, has not been standardized yet. And both R apps and X apps have been standardized in ORAN. Now the question is who actually has deployed ORAN currently worldwide? So that Andy, that if you can hear answer, please let me know. So the answer is the question is that it whole world, right? Throughout the whole world, not just the United States. Which providers? Any providers that has implement ORAN technology. Anybody? Andy? Does anyone have answer to that question?
You're saying worldwide, DJ?
Yes.
Anyone
Which
have an answer to
providers?
that?
Anybody?
It looks like the answer is no here in the room.
The reason I mentioned is that, so another reason I say take the promises ORAN with a grain of salt. There are only two providers in the whole world. The first one is Dish. That I think Dish changed their name, right? Andy, they changed to what? To what's it called now? Boost? Is that called Boost? Boost Mobile? Andy, am I
Boost
right?
Mobile, yes, we have confirmation.
Yes, correct. So Dish, yes, is utilize ORAN technology. The number one. The second one is called Rakuten. Rakuten in Japan. That's it in the whole world. So it's coming soon, I think. So to let you know. Okay, so the next few slides that I want to go over in terms of much efforts of adding those interface management techniques into different working groups that to such that the government can utilize ORAN, as we discussed, to support different applications, for example, supply chain or transact. So, so MITRE has successfully added that multiple interface management techniques to ORAN Alliance. The first one is working group number one, called that working group number one happened to have use case 26 that deal with interference detection and optimization. However, that is kind of 26 does not have PRP blanking, beam control, or carrier aggregation as we discussed previously. So Miter participated in Oil Alliance, started April last year, and we attended a bi-weekly call and went to face-to-face meeting in Incheon, South Korea, also Montreal, Canada. And so the outcome was good. And we added those interference management techniques to working group one use cases, analysis report, as well use cases detailed specifications. So that's the first accomplishment. And the second one called next generation research research group. As I mentioned, this is like at the research stage, and they also they were developing a research report called DApps. Remember, I mentioned DApp back in the orange slide. DApp really is to further that improve the time scale from 10 millisecond down to almost 1 millisecond. Think about 1 millisecond, right? To change the base station functionality within 1 millisecond time scale, that's really fast. In the old days, that when we were doing spectrum sharing, right, between 4G technologies, yeah, that it's called LTE, right? And the government system, I don't want to mention the name government system, but anyway, at that time, at that era, we had to reconfigure the 4G base stations to accommodate spectrum sharing objective. And at that time, it would take minutes, right? 10 minutes to modify, to configure even with just one attribute. So that was fine, right? At that time, remember that was many years ago, and we are grateful. We are grateful that 4G provider was willing to support us in that experimentation or testing. That no complaint there. I was grateful, but the point I try to make is that at that time, it would take minutes to configure even one attribute of a base station. Sometimes base station even had to reboot, right? Reboot itself to make the contribution to be effective for the base station. Clearly, fast forward to 5G today, that in order to do dynamic sponsor sharing between 5G and any government system, doesn't matter what it is, that minutes, right, to configure a 5G base station, probably too slow. So that's the reason Orange Alliance has been making progress to make sure the speed of configuring a base station can be faster and faster. And for NGRG, the DApp research report is to further accelerate the speed to down to 1 millisecond level. And this research is led by Northeastern University. I think they also got a grant from NTIA as well, probably from DoD as well, to conduct dynamic spectral sharing using DApps. So they make a tremendous progress in using DApp to support many applications, including spectral sensing, which is one of the important elements to do spectral sharing. So this is like a steps of the change request submitted by miners in terms of getting those capabilities for interference management techniques accepted in Ori Alliance. Now that since we added the interface management techniques to the use cases, now the next step is that we want to make sure that the ORIEN vendors can implement those interference management techniques inside their base stations. That I think there are few vendors that not few vendors, many vendors that in the ORIEN base station space. So that's the reason we engage with working group 3. And working group 3 is like a near real-time RIC. Remember, the RIC means when intelligent control. That's where they can host X app to influence and optimize the base station functionalities. And so we had to ensure the near real-time RIC is able to accommodate the PRB blank implementations. So we also submit a CR to Alliance Working Group 3 such that they can add PRB blanking into their specifications. So this CR has been accepted in Working Group 3. The next step is that we're going to add the PRB blanking into E2 service model into E2SM cell configuration control specifications. And this is probably too detailed for this presentation, but I want to let you know in case people ask that what's the next step. Okay, so I'm going to provide the summary in terms of what we have presented today. So even though we present a lot of, I call fancy, right? Fancy techniques that's like a PRB blanking, bin management, and the carriagation, right? Which is nice. But you look at the way vendors or providers doing coexistence techniques that they, they still leverage traditional cellular RF design principles. That, for example, antenna downtail, basically downtail antenna, such that the energy from antenna focus more near the base station instead of radio too far and cause unintentional interference. So that's antenna downtail, basically downtail antenna on the cell tower. Or you rotate the antenna to point to a different direction away from a government communication system, right? That's another possibility. The third one, you can reduce the transmit power level. Basically, you're changing the RF propagation environment created by the base station, right? You're changing the propagation environment. And by the way, those techniques have been used in 2G, second generation. When was 2G invented? 19 what? 1990 something, right? That I'm pretty sure before year 2000. That was what, 30 years ago? Am I right? And however, those techniques, right? Even though they are traditional, they are old, they're effective, right? Also cost little money. So those still techniques utilized by vendors, providers today. Just throw out there that even though we give a lot of fancy techniques, that don't forget that there's still traditional techniques that people still can leverage. Now we'll come to those what I call fancy techniques that, as I already mentioned, Orient Alliance has PRB blanking and other techniques. The issue, I would not say problem, that okay, the reservation for those fancy techniques is that it doesn't mean that all the vendors have those techniques, right? Remember those like more newer techniques, and it doesn't mean that every vendor, all the providers have the same techniques, right? because maybe they don't need that. Maybe they think their other techniques are better. So that is one reservation in terms of having the techniques doesn't mean support it, right? That's reason you have a anyway. So it's another point to consider when we look at this many techniques. Also, as I mentioned, National Spectrum Research and Development Plan also has similar techniques. For example, they also mention PRB blanking, beam stirring. Also, the specific mention already, as I mentioned that, because they already mentioned that in order to do spectral sharing, especially you have to do that in either in real time or near real time. So they sort of imply that ORAN is needed as a part of spectral sharing strategy. And I'm gonna skip this one. This will go into the classic way of doing spectrum sharing. For example, you partition the spectrum to different portions, or use a distance separation between 5G and the government entity asset, as well using database similar to CBS to do dynamic frequency selections. So that's another category of doing the spectrum sharing. Okay, finally, I come to a conclusion that so why we are adding VGPP interference management technique to all specification. So as I mentioned, even ORAN that may not get deployed, may not by too many providers, but it's coming along well. You can see a lot of announcement from AT&T is using, I think it's Ericsson as a integration vendor to deploy ORAN. And I think Verizon also consider adopting ORAN as well. And so many 5G providers are thinking or working on the initiative of adding 3GP of the ORAN technologies into their portfolio, right? That's so by adding 3GPP interference management technique into ORAN, then in the future, when ORAN products are ready, that the government can leverage those ORAN products as they are to do either dynamic expansion or other cases by adding government own X app. Where a government can add in their own intelligence features through software applications. And those foundation for interface management techniques are already there. The only thing you have to do is to call those functions that you can support whatever use case you have, especially agility. And also government also can leverage those techniques to do any future testing that government has in mind. So this concludes my presentations. And so Andy, is there any questions I can answer?
Hi, DJ. I've got a couple of questions that I'll pose myself, and then I'll encourage people to approach the mic if you've got some. One is in your opinion, is there any chance that 3GPP will take on the specification of those interfaces in the RUDU, CU, or are we always going to need another like ORAN alliance to do that, like a third-party spec?
Oh, this is an excellent question. May I ask who ask who asked this excellent questions?
Oh, who? That's my own. This is Andy. Andy Leides.
Oh, I'm sorry, Andy. No wonder. You are so great. Excellent question. That's kudos to you. So, um, 3GPP is, Andy, you know this very well as well, right? Andy, you also participate in 3GPP meeting. And 3GPP is an international standards organization. So basically, they have delegates from the United States, from Europe, from Korea, Japan, and China. And you probably know the answer, Andy. Who has the most number of delegates in 3GPP, Andy? Who?
It's not the US, it's China.
Exactly. So, and you look at Orient Alliance that also have delegates from different countries as well, and also from US, Europe, also China. But one of the famous vendors in China, they do not participate in Orient Alliance. Which one, Andy? Which one do you think? One of the Orient, 3G, basically base station vendors in China.
This is Huawei?
Yes. They do not participate in Orient Alliance. Why? So, and now the reason I mention all this story is I want to justify my answer. And Huawei has a huge presence in 3GPP. And Huawei does not support Orient Alliance. Do you think Orient has a shot to get included in 3GPP? What do you think?
Okay, yeah, I suspected that was going to be your answer. So thank you. A second question I've got is just in your experience with testing with Open RAN, is there an open 5G core that people are coalescing on, even on the experimentation side, or there's just a lot of diversity of 5G cores that are being used?
Oh, that's another excellent question. So 5G, open 5G core, the dynamics is is very different from Orange. And there are a lot of community that producing open 5G core, even for free. That so that has been used by many academic college, university, as well testing community to do testing. And that one is mature very well. So open 5G core is kind of different from 5G range. Because the reason is that another reason is that there's really a lot of patterns in a base station design, and not many patterns in 5G core. So people are more willing to open up the core, but people are not willing to open up the base station because there are a lot of patterns that's embedded in the base station design. So that's another reason. That's another difference between 5G core and the 5G base stations.
Okay, thanks, TJ. And my last question is, I saw in your bio that you're working on some testing on interference between NOAA SATCOM and potential 5G in the N79 spectrum. Anything you can share on that?
Sure. So basically that we did a testing at Yuma. Andy, have you been to Yuma?
I haven't been there, but I'm aware of the testing going on there.
Okay, so basically that Yuma has like a meetup terminal. Basically it's like terminal receive weather information from NOAA satellites. I think NOAA satellites kind of different from low Earth orbiting. They call polar orbiting satellite. They come into view maybe twice a day, and they will stay in view of the terminal maybe 10 minutes or 15 minutes. And it just happened that in that region, that they want to share the 5G spectrum with the provider there. I don't want to say the name of the provider. So we were asked to do testing to see how 5G will interfere with the meetup terminal when the terminal was receiving weather information from NOAA satellites, and how we can mitigate that, Andy. If you're interested, I can send you the testing report.
Okay, great, thank you. Open up in the room here or online in chat. Any more questions for DJ? Okay, I think that's it. Thanks very much, DJ. We appreciate your time.
Thank you. Bye.
Okay, we are going to be in line for a bit of a break here. Will Fong is going to be our next briefer. We're going to move him up a bit, but he doesn't think he'll be at a station until about 1400. So we'll plan on taking a 10-minute break here and come back at 1400 to hear from Will Fong with everything they're doing with 5G in the Indo-PACOM area of operations. He's out in Hawaii, so interesting stuff. Thank you.